Hey, welcome to our Chapter 6.2 video on evaluating and graphing polynomial functions. So we're going to start with evaluating functions, and before we get into that, just a little bit about polynomial functions. So a polynomial function is the function in this form here, f of x, that's for our function, equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 all the way down to a sub 1 x plus a naught, or a sub 0. Now, don't let that be too daunting for you. That's just a notation. We're not going to need to really do anything with this. A sub n can't be 0 because then that first term would go away. Okay. Our exponents are all going to be whole numbers, so this is going to be important here, these two things. Exponents are all whole numbers, so this might be 4, 3, 2, 1, 0. Okay, they're going to be in descending order. So up down here at the bottom, standard form is when you write it with your exponents in descending order. So the exponents are whole numbers, so there's no negatives, there's no fractions, because whole numbers are 0, 1, 2, 3, 4. Also, your coefficients are going to be real numbers. That means that none of our coefficients are going to have an I in them. Okay, and our A's are our coefficients. Coefficients, the part in front of the variable. Okay, we're going to call a sub n the leading coefficient. And we're going to call a sub o the constant term because it doesn't have a variable. And the degree of this polynomial is n. So your highest exponent is your degree. So for instance, if I gave you 5x to the 4th plus 3x squared, so you can have missing terms essentially, plus 1, that is my leading coefficient. We'll call it the LC. That is my constant. That is my degree. Okay, so we can use what type of function it is to help us graph it, which is going to be our end goal here today. So just these are 5 basic types of functions. First of all, the constant function, so it has degree 0, and it has degree 0 because there's no x in there, there's just that coefficient. Okay, so an example of a constant function might be y equals 3. So that is just the horizontal line at 3. Linear function you should be familiar with. It's degree 1 because your x there has a degree of 1. So we're looking at y equals 2x plus 5. Okay, so it's going to graph something like that. Next is our quadratic, which we just got done with in the previous chapter. Okay, it has degree 2. Okay, so y equals 5x squared plus 3x plus 1. And we know what it graphs, right? It's going to graph a parabola. Next is our cubic, and we call it a cubic because it has a cube in it. Okay, so it has degree 3. And it might be something like, well, we could just do y equals x cubed. And our last one, oh, and by the way, it's going to graph something that looks a little bit like that. And our last one is a quartic, and it has degree 4. Okay, and it could just be even something like y equals x to the 4th. And it can graph something like that. So have those written down and have their types by them, and then we'll talk about them in class. So one of the things we'll want to do is just to figure out, are these polynomials, and if so, can we write them in standard form and know their degree, their type, and their leading coefficient? So looking at this first one here, do you think it's a polynomial? Well, it's not, and it's not because it has a negative exponent. So is it a polynomial? No. What about the second one? Is it a polynomial? So your two checks are, does it have whole number exponents? And are the coefficients real? And 0.8 is a real number. So yes, this is. So descending form for exponents, I'm just going to rearrange these first two here. So f of x equals, and you're going to keep the signs with the terms, x to the fourth minus 0.8 x cubed minus 5. So that's now in descending order. The degree is going to be 4, because that's my highest exponent. The type, since it's degree 4, it's a quartic. That's from the previous slide. And the leading coefficient is 1, because there would be 1x to the fourth. So we're going to evaluate polynomials using two different kinds of substitution. So first of all, direct substitution is just you plug in the given value. So an example for direct substitution is going to be if I have 5x plus 2, and it's going to say evaluate for x equals 3. Well, you've been doing this a long time. You just say 5 times 3 plus 2, which is 15 plus 2, and you get 17, and you're done. That's direct substitution. The other one is synthetic substitution, and I'm going to wait to show you in class, but it's a process of using the coefficients of terms and the numbers you're evaluating to determine the evaluated value. So what that means is really all of this just depends on your coefficients. So we can kind of eliminate the x part, and it's just a different way of looking at it. So I will show you that in class. Right now just have that example written down and the difference between direct and synthetic. So the last part of this section is going to be graphing. And when we graph, you can graph anything just by making a table. Remember that. If I can graph any of these polynomials by just making a table, and that's what you're going to do. And so what we're going to want to do is we're going to want to look at the end behavior, and that will tell us really if we're done graphing or not. So the end behavior describes how the graph is going as it approaches either positive or negative infinity for the x. So for instance, if I just plotted a line here, then we would say, here, we'll do it this way, as x approaches positive infinity, so as I come this way on my x's, my graph is going towards what as a y value? Well, it's going to keep going towards y, towards positive infinity for y, right? It's going to get way up here. So as x approaches positive infinity, we say f of x, that's our y value, approaches positive infinity. And then our other one is going to be as x approaches negative infinity. So as we come this way on our x-axis, what's my graph doing? Where's it going for the y values? For the y values, it's headed towards negative infinity. So f of x approaches negative infinity. It's all based on where x is going. So you always start with your x. So here's our 4 options for end behavior, and at the moment I really just want to jot it down and then we'll go over this in class. So it depends on if your degree is even or odd, and then it depends on if your leading coefficient is positive or negative as to then what your end behaviors will look like. So at the moment I want you to jot that down and then we will talk about it in class. Okay, let me know if you have any questions and have a good day.